Hey guys, today we're going to finish up section 4, and it's also going to finish up our chapter as well. We're only doing these 4 sections in the chapter. Now, we're not going to have 2 quizzes and a test. We just don't have time for that. Okay, so what we're instead is just going to have a test here at the end. Okay, so we're going to actually do 2 days of review before that test though. So tomorrow will be a review day. I'll get the ones that you guys didn't understand. I'll make a video again. You can watch that video for the second review day, and then I'm going to give you a few more problems on a Google form just to practice a little bit more. Okay, and then you'll end up having your test after that. So again, we're going to have 2 days of review after this, opposed to just 1. So hopefully you guys will be able, if you have questions, get them answered. Okay, so what we're going to look at today is we're going to look at some more composite shapes, okay, which means where we have to add and subtract things. Okay, we did a bunch of them with subtracting, okay, a few days ago. Now we're going to do some where we can do some adding as well. Okay, so if you look at the first one you've got here, you'll notice this isn't a shape that we have a name for. Okay, but you will notice it is broken into some shapes we have names for. Okay, I've got a rectangle here and I've got a triangle here. Okay, so to find the area when it's not a border, okay, there's not one inside of the other, but instead they're attached to each other, we want to add the areas. Okay, so in this case, I would take the area of my rectangle plus the area of my triangle. Now, it doesn't matter if you want to flip those around because in adding, the order doesn't matter, so it doesn't matter to me either. Okay, so for a rectangle, it's going to be base times height. For a triangle, it's going to be 1/2 base times height. Okay, so then we just have to check and see if we have everything we need, or if we're going to have to find some other pieces as well. Okay, so if you look at your rectangle, you do have your base and height with the 10 and the 8. Then if you move to the triangle, it doesn't look like you have the base, but if you think about a rectangle, if that's 8, then this side has to be 8 as well. So it turns out the base of our triangle is also 8, and then the height, which again always has to be at a right angle, is 6. So on this one, they really gave us everything we needed. Okay, we just needed to identify it and plug it in. There's no pi's, no square roots on this one, so you can just go ahead and plug it in the calculator, and you'll end up getting 104. And again, I'll put labels here, but you do not need labels on your Google Forms. All right, if we go ahead and look at the next one. Now the next one can actually be done 2 different ways. I'll talk about both of them and then we'll just use one of them. Alright, so on this one again, you've got 2 options. Some kids will use the trapezoid and the semicircle, which is perfectly fine. Some kids will draw in this height and they'll use triangle, rectangle, and semicircle, which is fine. You actually will get the exact same answer no matter which way you tend to do it. Okay, I'm going to go ahead and do trapezoid and semicircle, but if you would have preferred the other way, it wouldn't have been a problem at all. Okay, so I'm going to do area of trapezoid plus area of semicircle, or half a circle is basically what we'll do. Okay, so for the area of my trapezoid, that's 1/2 height, base 1 plus base 2. For my semicircle, it'd be 1/2 pi r squared. Okay, so if we look here, I don't know the height of my trapezoid, but I have to find it. Okay, we'll find it the same way we did earlier in the chapter. Okay, if this is 22, then this is 22, which since the whole thing was 31, leaves 9 left over here. Okay, I can now use my Pythagorean theorem to find my height. Or if you notice, it is a Pythagorean triple. Okay, it does end up being 12. If you didn't notice that, then again, go ahead and use the Pythagorean theorem. Okay, so I have a height of 12 with my trapezoid. My bases are 22 and the whole thing, which is 31. Plus pi, half of our pi r squared. Okay, well, using the height, if that's 12, this is 12, which tells me my radius is going to be 6. Okay, 6 squared is 36. Okay, then it's a matter of simplifying it. Do not combine pi stuff with regular stuff. Okay, so you would just put the first part in the calculator and get 318. Half of 36 is 18 pi. Again, do not put those together. Do not put those in the calculator. Keep them separate from each other with the pi. All right? Next one we're going to look at, C, actually has a couple ways it can be done as well. Okay? And again, it's just kind of how you prefer to break them apart. Alright, so for this one, essentially what most kids will do is break it into two rectangles. Just depends on where you want to break it apart. Okay, one option you have is you could go right here, okay, and break it into these two rectangles and add those together. The other one you could do is you could have gone right here and broke it into two, or it breaks it into three. Again, doesn't matter as long as you just find things correctly. Since I drew this one first, I'm going to go with this one. Okay, so it's two rectangles, so it'll be area of rectangle plus area of rectangle. Okay, so if I do the top rectangle, it's fairly easy because I have the 13 and I have the 6. This one I have 7, but I got to find out this part. Okay, well, if the whole thing was 13 and I have 8 here, that leaves me 5 for this guy. Okay, so it ended up being 7 times 5 for the other one. Now again, if you broke it up differently, your numbers would change a little bit, but you would end up with the same answer in the end. Okay, no pi's, no square roots, so you can just go ahead and multiply those together, and you'll end up getting 113 for those. Okay, so again, break it up how you'd like, but make sure that you can find the correct pieces. Okay, for D, again, there's going to be two ways you can break this one up too. Alright, so this one we're going to break into a trapezoid and a rectangle. It's kind of up to you which way you want to do it. I tend to do it this way. But if you wanted to do it this way, you could have as well. That's fine. Okay, it doesn't really matter to me either way. Okay, but you do end up with a trapezoid and a rectangle. So we'll do area of the trapezoid plus area of the rectangle. So trapezoid is our 1/2 height, base 1 plus base 2. Rectangle is base height. Okay, so we need to make sure we got our pieces here, so I need to get this cut apart. So if that's 5, that would mean this is 5. So since the whole thing was 12, that means this would have to be 7. Okay, so if I do the trapezoid first, the height of my trapezoid will be 7. And the bases of my trapezoid will be 8 and then 15. Because again, if the bottom's a rectangle, okay, 15 and 15. Plus, okay, base and height of your rectangle will be 5 and 15 as well. No pi's or square roots on this one, so you can go ahead and combine them all together, and you'll get 155.5. It's okay to have a decimal because there's no square root and there's no pi. If there was, then I would have to turn it into a fraction. We're going to skip E. It's just more than what we need to do right now. That one's a little bit trickier with some things. So we're going to skip that one, and instead we're going to look at F. so what you have here is you have a parallelogram and you have a kite. Now notice this one's a little bit different because the kite is being cut out of the parallelogram. Therefore, we have to go back to our subtracting anytime something's being cut out. Okay, so the bigger shape is the trapezoid, and then I'm going to subtract the kite. Again, if they're attached, you add. If they're cut out, you have to subtract. Okay, so for the, or excuse me, not trapezoid, sorry about that. That's a parallelogram, not a trapezoid on that one. Okay, so area of a parallelogram is just base times height. Area of a kite is 1/2 diagonal 1 times diagonal 2. Okay, so for our parallelogram, we have our base and height. Okay, our 9 and 14 would be our base and height. A nice thing about this one is you actually have your diagonals as well. Okay, because of the parallel line markings, which you guys have in your diagram, if this is 14, it would mean the one in the middle is 14 and the one down here is 14. They would all be the same. Same this way, if this is 9, okay, then this one would have to be 9 and that one would also have to be 9. Okay, or excuse me, just these two would be 9 because that's not, that side would match up with that side. Okay, but you end up getting your diagonals to be 14 and 9 as well. Again, no pi's or square roots, so you can just go ahead and put it all in the calculator, and you'll end up with 63 feet squared. All right? So again, I know these problems can be a little bit tricky when you always have to add and subtract things, but do the best you can with them. Send me an email if you have a question. I'll help you out as best I can. Again, we'll spend 2 days reviewing for the chapter test. Okay, before we end up having that. Okay, yeah, that's all I got. Have a great day.